Today we're going to solve a rocket problem in physics. So a rocket accelerates upward at 15 meters per second squared for 10 seconds, starting from rest. After 10 seconds, the engine cuts off. What is the maximum height will the rocket achieve, and what is the rocket's total flight time? So to solve this problem, what we need to do is plot in some points. So let's say on point B, this is when the, the engine of the rocket cuts off. So after it cuts off, of course it will have a free fall, but before it free fall, it do have a momentum that will eventually make it to the point C. So point C is going to be the maximum height. So let's calculate it. So first of all, let's calculate the distance from A to B. So we already know the kinematics equation. So we're going to also calculate the distance from B to C. So the H max is the combination or the sum of the distance from A to B and the distance from B to C. So let's try this. So first, let's calculate the distance from A to B. So we could do that if we know the final velocity from point B. So let's use this equation. So we can just cancel B initial because it is started from rest, right? So let's just slash this out. So the V final, that's what we're going to calculate, which is going to be the final velocity or the final velocity after the engine cuts off. So VV is going to be 15 times 10. So let's try this. So the final velocity before the engine cuts off is going to be 150 meters per second. Now, as we know the final velocity in that point, what we can do now is use another kinematics equation for us to calculate the distance. So let's use this. So we got B final squared equals to B initial squared plus 2 acceleration times distance. So as we know that V initial squared is going to be 0. Let's cancel it out. So we got 150 squared here. And we can just manipulate this equation. We can just divide both sides by 2a. So we get this. So let's put the numbers. So acceleration is going to be 15. And we have distance from A to B. So the distance from A to B is going to be, let's use our calculator here. 150 squared divided by 2 times 15. That's going to be 750 meters. So it is a little bit far. So how tall is that? Now we know the distance from A to B. Let's calculate the distance from B to C. So after the rocket's engine cuts off, it will have a momentum that will reach the rocket to point C. So we do not have any acceleration. We only have the gravitational acceleration due to gravity. The acceleration due to gravity. What did I say there? So we can just name things here. So the B initial now is going to be the final velocity after the engine cuts off. And the final velocity, which is V sub C, is going to be 0. Because we're not going to have final velocity within the point C. So now we're going to manipulate this equation and solve for the distance from B to C. So we're going to plug in everything that we know now. So the distance from B to C is going to be negative quantity 150 squared divide 2, and we're going to put negative 9.8 meters per second now, squared now, instead of 15 meters per second squared. So that's going to be 1948. So there's a lot of momentum that made it reach to point C. It's much more further than 750 meters. So H max is going to be 1148 plus 750. Okay, so now let's we can use compute this manually, but I'm still going to use calculator. So we got 1,898 meters. So that is the maximum height that the rocket achieved. So this is not enough to escape the Earth's orbit. Now let's move on to our second problem. What is the rocket's total flight time? So how many seconds? Yeah, just seconds. I know this is quick. Does it fly from A to B to B to C to D? So how long until it just hit the ground and explode? So the time, so we already know the time it takes from A to C. That's going to be 10 seconds. But we do not know the time it takes from B to C. So we already know the distance. That's going to be 1148. And we got 750 on the way to A and B. So distance from B to C, let's just use this equation. We have the to average velocity divided by 2. We're going to multiply this by time. So the time here is going to be B to C. So we use this equation because we already know what's the certain values. So this is going to be the distance from B to C. That's going to be equal to, okay, let's not remove this. Let's use this as our guide. So this is going to be BV plus VC. We're going to calculate VC because at the top, the velocity is just going to be 0. So we leave us with the initial velocity. So we're going to multiply this by the time. So we're just going to manipulate our equation. So we will have this. So this is easy to manipulate our equation if you master the algebra. I also have a algebra playlist. But wait, so yeah. So just watch it. So 2 times 148. So that's 1148. I thought that's 1. So that's 1148 divided by 150. So the time it takes from B to C. So yeah, let's put some units here and numbers. Okay, so the time it takes from B to C is going to be 15.31 seconds. So that's pretty much long enough for us to reach from point C, which is the maximum height. Now let's try to calculate the time it takes from C to D. So I think this is much more quicker because it's accelerating downward from negative 9.8 meters per second squared. So that's 9.8 per meters per second squared. That's pretty much fast. So we can just use this equation. Distance equals to B initial times time plus 1/2 acceleration times squared. And the distance here is going to be the maximum. So let's just put some equations here. So VC is cancelled. We already know that there's no velocity at the highest point. So we get this equation. So now we can just plug in what we know here. And let's manipulate our equation. It's just a little bit manipulation. So we got H max times 2. And we can just divide this by acceleration and take the square root of the time. So we get this. Okay. Let's just delete this and let's plug in what we know. So let's plug in everything. Are you excited or what? This is just quite exciting if you know everything. So the 2 times 1898, that's the maximum height that the rocket have reached. We got divided by 9.8. So we're not going to use some negative sign here because time is absolute. I mean, it does have a radical sign, and we do not want a negative time. So we get 19.68 seconds. I thought it's going to be much quicker, but yeah, I think it's pretty much slower because of the massive distance, the large distance. So the rocket's total flight time we can calculate it by adding all of this. So from time to A to C, from B to C, and the time from C to D. So we can just approximate it to 45 seconds. So that's it. That's the flight time of the rocket, total flight time.